Welcome to Module 6, where we focus on documented information in IATF 16949. The objective of this module is to understand what kind of documentation is required under the IATF 16949 standard. This includes mandatory documents, the quality manual, control plans, process flow diagrams, and document control procedures. This documented information is essential for ensuring standardization of processes, maintaining traceability, and demonstrating compliance during audits. In the upcoming slides, we'll go through each of these document types in more detail. Let's begin by understanding what documented information means in the context of IATF 16949. It is a broad term that includes documents like procedures, work instructions and specifications, and records like inspection reports, training records, and audit findings. Now, why is this important? It ensures consistency, so processes are followed the same way each time. It provides evidence that we are meeting requirements. It allows for knowledge transfer, especially helpful when employees change or new ones join. It improves communication, as everything is clearly defined. Most importantly, it ensures compliance with IATF 16949 and customer-specific standards. A key principle to remember: if it's not documented, it didn't happen. Especially true for critical activities. Example: if a new employee joins and there are no documented work instructions, they might do a task incorrectly, leading to poor quality, but a documented training record can prove they were properly trained. This slide focuses on the mandatory documents and records required by IATF 16949. These are non-negotiable. Organizations must maintain them. Let's go through each required item, along with examples. 1. Scope of the QMS, Clause 4.3. This defines the boundaries of the quality management system. Example: a document stating, "This QMS applies to the design, manufacturing, and servicing of automotive braking systems at our Delhi facility." 2. Procedures for addressing risks and opportunities. Clause 6.1.1. Organizations must document how they handle risks and opportunities. Example: an FMEA procedure or a risk register template. 3. Quality objectives. Clause 6.2.1. These are measurable targets related to quality, documented at different functions and levels. Example: reduce customer complaints by 10% by Q4 2025. 4th, evidence of competence. Clause 7.2. This is proof that employees are trained and competent. Example: training matrices, certificates, or skill assessments. In this module, we are discussing the documented information required by the IATF 16949 standard. First, we have evidence of awareness. Clause 7.3. This proves employees are aware of the quality management system, policies, and objectives. Documents like training attendance sheets or sign-off sheets can be used as evidence. Then comes evidence of communication. Clause 7.4. We must keep records of how we communicate internally and externally, like meeting minutes, customer and supplier communication logs. Next, evidence of suitability and effectiveness of monitoring and measuring resources. Clause 7.1.5.1. We need to keep calibration records for tools like micrometers and calipers. Results of calibration and verification. Clause 7.1.5.2.1. Should show specific readings and results, for example, pass or fail readings on calibration certificates. Moving to design and development. Design review evidence. 8.3.4. Includes review meeting records or DFM reports. Design verification evidence. 8.3.4. Includes test reports from environmental or vibration testing. Design validation evidence. 8.3.4 includes PPAP documents, trial run reports, and customer approvals. Let's continue with more documented information required by IATF 16949. First is Evidence of Design and Development Changes, 8.3.6. This includes documentation of any changes made to the design or development and their approval. Example, ECNs, Engineering Change Notices, or ECOs, Engineering Change Orders. Next, Characteristics of Products and Services to be Produced, 8.5.1. This includes specifications, drawings, and requirements. Example, Engineering Drawings, BOM, Bill of Materials, and Material Specifications. Results of Review of Requirements, 8.2.3. This is the record of order or contract review. Example, Sales Order Acknowledgement and Customer PO Review Checklist. Evidence of Control of Externally Provided Processes, 8.4.1. This includes supplier records and evaluations. Example, Approved Supplier List, Supplier Audit Reports, and Performance Monitoring. Evidence of Unique Identification of Outputs, 8.5.2. When traceability is needed, we keep lot numbers or serial numbers. Example, Production Batch Records, Product Labels with serial numbers. Lastly, records of property belonging to customers or external providers, 8.5.3. We must keep records of tools or equipment owned by customers. Example, Customer Property Register and Inspection Records. Now let's look at more important documented information required under IATF 16949. Records of Production Service Provision 8.5.6 includes records of what was produced or delivered. Example, Daily Production Logs, Dispatch Records. Evidence of Product and Service Conformity, 8.6. This shows whether the product meets the requirements. Example, Final Inspection Reports, Certificate of Conformance, COC. Records of Nonconformity and Actions. Taken, 8.7.2. Whenever there is a defect or problem, we must record the issue and the corrective action taken. Example, NCR, Non-Conformance Report, 8D Report. Results of Monitoring and Measurement, 9.1.1. This includes data used to evaluate performance. Example, SPC charts, OEE data. Evidence of Internal Audit Program Implementation. 9.2.2. We must record audit schedules and results. Example, Internal Audit Schedule, Audit Reports. Results of Management Reviews. 9.3.3. Minutes from Management Review Meetings. Example, Meeting Minutes with Action Items. Results of Corrective Actions. 10.2.2. This shows how effectively problems are resolved. Example, Corrective Action Request Closure Report with Verification. Discussion. Tip. Ask participants to name 2 records that are important in their own job and how they make sure those records are updated and maintained. Now we'll discuss the Quality Manual, as required by IATF 16949, Clause 4.3.2. The organization must establish and maintain a quality manual. But what exactly should be included in that manual? First, the scope of the QMS, which tells us what the quality management system covers. Second, justification for any exclusions. If something is excluded, it must be permitted by IATF and clearly explained. Note, very few exclusions are allowed. Next, it should explain the documented processes required by IATF 16949. This doesn't mean putting all procedures in the manual, just explain how the system works. Also include the interactions between processes, either through a process map or a narrative. This helps visualize how one process leads to another. Finally, a matrix showing how customer-specific requirements are addressed. So overall, the Quality Manual is the top-level document that helps everyone understand how the QMS operates. Let's understand the purpose and format of the Quality Manual. The purpose of the Quality Manual is to act as a high-level roadmap of the QMS. It gives a complete overview of how the organization meets the IATF 16949 requirements. This is often the first document that an auditor or customer reviews, so it must be clear and well-organized. Regarding format, there's flexibility. It can be a single document, a series of related documents, or even part of an electronic system. The key is, it should be easily accessible and maintained at all times. As an example, you could share a sample Quality Manual's table of contents, especially the sections that cover Scope of QMS Process, Map Customer-Specific Requirements Matrix. These are essential areas to highlight in every Quality Manual. Let's now talk about quality objectives, as required under Clause 6.2.1 of IATF 16949. Organizations are required to establish quality objectives at relevant functions, levels, and processes. Good quality objectives follow the SMART principle. Specific. They must be clearly defined. Measurable. You must be able to measure performance against them. Achievable. Objectives should be realistic considering the available resources. Relevant. They should align with the organization's quality policy and business goals. Time-bound. There must be a defined time frame or deadline. They must also link to the quality policy, meaning they support and reflect the direction the policy sets. Objectives must be monitored, communicated, and updated as needed. So, how are quality objectives created? They're often derived from management reviews, risk assessments, customer feedback, performance data. Make sure the objectives are not just created once and forgotten. They should be a living part of the QMS. Let's now look at a practical example of a quality objective. A poor objective would be improve quality. This is too vague. It's not clear what to improve, by how much, or when. A good objective would be reduce internal scrap rate from 2.5% to 1.5% by end of Q3 2025, specifically for Part A as measured by production reports. This is a SMART objective: specific, measurable, achievable, relevant, and time-bound. Now, let's do a quick activity or discussion. Ask participants to think of one quality objective that is relevant to their own department, and then share how they would make it SMART. Encourage sharing across teams. This promotes learning and real-time alignment with the QMS. Now, let's discuss process flow diagrams, which are required under Clause 8.5.1.1 of IATF 16949. Organizations must use a multidisciplinary approach. That means involving different departments, like quality, production, and engineering, to create these diagrams. The purpose of a process flow diagram is to visually represent the sequence of operations in a manufacturing process. Why is this important? It helps everyone understand the process clearly, from start to finish. It helps identify bottlenecks or areas where the process could be improved. Most importantly, it serves as the foundation for developing FMEA, failure mode and effects analysis, and the control plan. A good process flow diagram sets the stage for better quality and smoother operations. Let's now talk about control plans, which are covered under Clause 8.5.1.1 of IAT F 16949. The requirement says that organizations must develop control plans at every level: system, subsystem, component, or material, for all supplied products. The purpose of a control plan is to document the methods and controls used to ensure product quality throughout the manufacturing process. It's a living document, meaning it should be updated as processes change. Key elements of a control plan usually include process step, based on the process flow diagram, machine to our device, what equipment is used, characteristics, what is being measured, like temperature, dimensions, pressure, specifications, tolerances, acceptable limits, measurement techniques, how it's measured, e.g., calipers, CMM, visual, sample size, frequency, how often and how many samples, control method, like SPC, Poka-Yoke, or manual check, reaction plan, what to do if something goes wrong, responsible person, who's accountable. So, the control plan ensures everyone knows what to do, how to do it, and what to do if something goes wrong. Now we are looking at control plans under Section 6.3.2 of the IATF 16949 standard. According to Requirement 8.5.1.1, organizations must develop control plans at different levels: system, subsystem, component, or material, for the products they supply. The purpose of a control plan is to document the methods and controls used to ensure quality throughout the manufacturing process. It's not a static document, it's a living document, which means it should be regularly updated whenever there are changes in the process or product. Now, let's go through the key elements of a control plan. These are usually presented in a table format. Process step, the specific step in the process, matching with the process flow diagram. Machine to device, what equipment is used in that step. Product or process characteristics, what we are controlling, like dimension, temperature, or pressure. Specification or tolerance, what are the acceptable limits. Measurement technique or gauge, how it's measured, for example, using a caliper, CMM, or by visual inspection. Sample size to frequency, how many parts are checked and how often. Control method, how we maintain control, such as using SPC, Poka-Yoke, or operator checks. Reaction plan, what action to take if something goes wrong, such as stopping production or informing a supervisor. Responsible person, who is accountable for each step. These control plans help ensure consistent product quality and help us respond quickly if there's a problem. Let's now look at the different types of control plans. Depending on the stage of production, we have three main types. 1. Prototype control plan. This is used when we're working on initial samples, mainly for early development. Second, pre-launch control plan, used during pilot runs or trial production before mass production starts. 3. Production control plan. This is used for ongoing production to ensure everything stays under control. Now, a very important point. Control plans are directly linked to process FMEAs. That means any risks or potential failures identified in the FMEA should be addressed through specific controls in the control plan. This connection ensures consistency between risk management and actual process control. For example, you can take a small section of a production control plan, maybe for a specific dimension or tolerance, and show how you would fill it with real data. Pay extra attention to the reaction plan column that's critical when something goes wrong. As an activity or discussion, think about a common quality issue you've seen at work. How could a well-designed control plan, especially a strong reaction plan, have helped prevent or quickly fix that issue? This section covers document control and retention requirements as per IATF 16949, which builds upon ISO 9000 and 2015, Clause 7.5.3. The purpose here is to make sure all documented information is available when needed, suitable for use, and properly protected. Let's go over some key requirements for controlling documents. Approval before release. Every document must be reviewed and approved for adequacy before it is issued. Review and update. Documents must be checked regularly and updated if needed. Reapproval is also required after major changes. Change identification. All changes must be clearly highlighted, like revision numbers or using change marks. Availability. Documents must be accessible to users at the point of use. Legibility and identification. Documents must be easy to read and correctly identified. Obsolete document control. Old versions should be removed from use to avoid confusion. Integrity protection. Make sure documents are secure and not altered without authorization. Examples of tools used for this: document master list, version control procedures, templates, or electronic document management systems. This slide focuses on records control as defined in ISO 9001:2015, Clause 7.5.3. Unlike documents, which guide action, records are the evidence of the results that have been achieved. To effectively control records, several requirements must be met. Identification. First, what exactly is the record? For example, a daily production report, line 3, clearly identifies what and where. Storage. Where is the record stored? It could be a physical folder or a digital location, like a shared drive. Protection. How are we ensuring that the record is not lost or damaged? Options include using backups or secure servers. Retrieval. Can we access it quickly when we need it? Using indexing and naming conventions helps with fast retrieval. Retention. This is critical. How long do we need to keep the record? This varies depending on legal, customer, or standard requirements. Disposition. After its retention period, how do we dispose of the record securely to ensure confidentiality and compliance? Examples include retention schedules, archive rooms, or electronic archiving systems. This slide covers retention requirements as defined specifically in IATF 16949. IATF 16949 has additional retention requirements, especially for key records like APQP, PPAP, and production parts. The minimum retention period for production part approval records, like PPAP, and tooling records, if applicable, is for the entire period the part is in production plus 1 calendar year. Important note, this is just the minimum. If a customer-specific requirement, CSR, asks for a longer period, you must follow that. Always go with the longer retention requirement. The organization must also ensure supplier records follow the same retention rules. Finally, disposition. After the retention period is over, records should be disposed of properly, like shredding or secure deletion, to maintain confidentiality. This slide brings it all together with an example, a discussion prompt, and some key takeaways. Example: a PPAP was approved in 2020. Production stopped in 2028. As per IATF, we must retain records till 2029, 2028 plus 1 year. But if a customer-specific requirement, CSR, demands 15 years, then the records must be kept till 2035, 2020 plus 15 years. Activity discussion. Let's discuss real-world issues with document control. Ever face challenges in finding the latest version of a document? Or misplaced records? What steps can your company take to ensure robust document control? Key takeaways. Documented information is vital for compliance and evidence. Maintain all mandatory documents and records. Quality manual and SMART objectives are the base of your QMS. Process flow diagrams and control plans are essential for process control. And finally, without robust document control, including clear retention periods, your QMS will struggle to stay effective. As we wrap up Module 6, let's focus on 3 important closing points. Emphasis on live documents. Documented information should not be static. Documents and records must be reviewed regularly, updated when changes happen, and actively used in day-to-day operations. This keeps your system relevant and audit-ready. Second role of every employee, every team member, from top management to shop floor operators, has a role in maintaining documented information and following procedures. It's not just the quality team's job. 3. Q&A session. Let's open the floor to questions now. Any doubts, challenges, or real-world situations you'd like to discuss?